In this video, we're going to be looking at section 5.1 on antiderivatives and indefinite integrals. Now, this is in chapter 5 on integration, and it begins with introducing f as the antiderivative. So here we have a capital F, and it's the antiderivative of my function f if when you took the derivative of capital F of x, you got the function f of x. So in a sense, we're going to be going backwards from what we did when we were learning derivatives. So here it says if my antiderivative function f of x was x cubed over 3, then f of x was x squared, because the derivative of x cubed over 3 is x squared. So, but the thing is, if I have capital F of x equals x cubed over 3 plus 6, the derivative of that is also x squared. So there are constants that would become 0 if you took the derivative. Therefore, we say that capital F of x equals x cubed over 3 plus this c is really the antiderivative of this, because there could have been some constant c that became 0 when the derivative was taken. So here c represents a number that could have been there. Theorem 1, if the antiderivatives of two functions are equal on the open interval a, b, then the functions differ at most by a constant. Symbolically, if capital F and capital G are a differentiable function on the interval a, b, and their derivatives are equal in a, b, then they are just different by some number c. So let's look at example 1 and see if we can make sense of this. It says find all the antiderivatives of f of x equals 3 times x squared. Well, we know that the derivative of x cubed is 3x squared. So all the antiderivatives, I'm sorry, we don't want to put the derivative symbol there. All the antiderivatives would just be x cubed plus c. And c could be different depending on what the original function was. Then b wants us to graph this antiderivative of f of x, passing through the point 0, 0, 0, 1, and 0, 2. So I'm going to show you that on Desmos. You can see here the red function is y equals x cubed. The blue function is y equals x cubed plus 1. And the green function is y equals x cubed plus 2. Now I added a slider to my red function, so currently c is 0. And you can see that antiderivative is going to be the same function that could be slid up or down depending on what c is. So let's graph these on our notes and answer part 3 or part c. So there are those three functions graphed in part B, and it asks how are the graphs of the three antiderivatives in part B related. So we'd say something like they are the same function. Oops. Try this. They are the same function. Don't know why it's doing that. With a different constant. Different constant. Just slid up or down. All right. Let's go on. We're going to get a few more definitions, but really it's all talking about the same thing. Here, we're going to use this symbol in order to represent the antiderivative, and we call it the integral. So we use this little squirrely s symbol and call it the integral of the function f of x when we take the antiderivative. The function f of x is called the integrand, So this is called the integrand. The symbol dx indicates that the antidifferentiation is performed with respect to the variable x, and c is called the constant of integration. So here are some indefinite integrals of basic functions. So if we have the power function and we want to take its integral, what we're going to get is, just like when we took the derivative, we subtracted 1 from the exponent and multiplied it by that value. Here we're going to add 1 to the exponent and divide it by that value when we take the integral. And then we'll always write plus c. And this is the reverse of the power rule. Now, the integral of e to the x, luckily, is e to the x. We kind of like that one. Now, remember the derivative of natural log of x was 1 over x. So the integral of 1 over x is the natural log of x plus c. So these are the reverses of the rules that we learned in chapter 4. Now for k being some constant, if you have a number just like 3 multiplied and you want to take it times the integrand and want to integrate it, you just integrate the function and then multiply the answer by that number. Same thing if you have 2 functions really to integrate, you just integrate each of them and add them together. So let's look at this in terms of our next example. Here in example 2, the integral of 2 dx. Well, I don't have a variable, I don't have anything. So if I integrate this, I'm going to get x. And then we said if you're integrating it, okay, so this is the way they'd want you to write it officially. They would go, okay, 2 is a constant, so I can bring it out front. So it'll be 2 times the integral of dx. Well, the integral of dx is x. So this is going to be 2 times x. And then we don't forget the plus c. That's actually going to be a point of that we're really going to want you to remember. So we could say capital F of x, the integral would be 2x plus c. Let's look at our next one. So here, what this rule says is if you have some constant, oops, just pull it out in front. So we could say we're integrating e to the t with respect to t. So the integral of e to t is just e to the t power. The 16 just gets multiplied by it, and we add the plus c. That would be our integral function. Here, we'll move the 3 up front. So it'll be 3 times the integral of x to the 5th over 5, excuse me. Remember, we do the opposite. This is the rule right here. If you want to integrate a power of x with respect to x, you add 1 to the exponent and divide by that same number. So that's what we're doing here. We added 1 to 4 and got 5, and we divide by 5. This will become 3/5 x to the 5th plus c. Now, do you have to show this step? You do not. But just to clarify the rules, I did. Now, question D is essentially what they're doing in 5 here. If you want to integrate 3 different terms, just integrate them individually and combine them. So here, 2, this will become x to the 6th over 6. Then minus 3, this will become x cubed over 3. And plus 1 will just become x. And then we'll throw our plus c in here. Our last step will be to simplify these. So if I have a 2 in the numerator, or being multiplied by a 1/6, whatever, we get 1/3. So that'll be 1/3 x to the 6th. This will be just minus x cubed because these 3's cancel. And this will be plus x plus c. Let's go on to this one. Now, don't be tricked by this. This looks a little complicated, but I'm going to rewrite it this way. I'm going to call that 5 being multiplied by 1 over x dx. And this is like minus 4 being multiplied by the integral of e to the x dx. The reason I do that is because this right here, if we go up, what does that equal? We go up here, that is the natural log of x. So we come back down here and we're going to call this 5 times the natural log of x, and then minus 4 e to the x, because the integral of e to the x is e to the x plus c. All right, let's keep rolling. Let's try these next few and see how we do. Here they're going to get a little more complicated because we're working with fractions, but you guys can do it. Before I do this one, I'm going to take this one step. You guys don't have to write it, but I'm going to. This 2 is just a constant, so it'll be multiplied by whatever the integral of x to the 2/3 is. And then minus, I'm going to rewrite this as 3 times the integral of x to the -4, because using the power rule is a lot simpler. Now, when we get our answer here and we take the integral, we'll have 2 times, this was a 2/3, so if I add 1 to that, we're going to get 5/3. So 2 times x to the 5/3. But remember, we have to divide by that new exponent. And this will become 3. And if I add 1 to -4, I actually get a -3. So this will be x to the -3 over -3. And then we have plus c. Now, of course, we can't leave it this way. We must simplify it. So cleaning this up, the 2 is a whole number. I'm going to do this kind of, maybe we'll do this real lightly in yellow. This is like 2 over 1. Now it's being divided by 5/3. When we divide by a fraction, we flip that fraction and multiply. So what we'll really have when we flip 5/3 is 3/5. Multiplying that by the 2, we'll get 6/5 x to the 5/3. And here my -3's will cancel, and it will become plus x to the -3 plus c. You can always check your answer, take the derivative, and see if it works. So you would take this answer, its derivative, and see if you wound up getting that, because the derivative of c is 0 because it's a constant. Let's go ahead and do this one. On b, we have 4 times the 5th root of w cubed. So we'll write that as 4 times the integral of w to the 3/5 dw. Meaning, so what will my new exponent be? Power rule. Well, we'll have 4 times, this will become w to the 8/5, and then we'll divide that by 8/5 plus c. Then we'll have to simplify it. Go ahead, try to simplify that, and we'll come back. So when you simplify that, you should get 5/2 x to the 8/5 plus c, because this 4 is the same as 4 is over 1. And when we divide by 8/5, that's the same as multiplying by 5/8. Those cancel, and we get 5/2. Now, this one looks really hard on C, but it isn't. Notice that, well, we haven't learned how to take the integral of a fraction yet, except for the natural log. And this doesn't look like that. So let's just split this up into 2 fractions. If you see something like this, we're going to try and simplify it first. So we're going to write this as the integral of x to the 4th over x squared. If we break it up, it's going to be so much easier. 8x cubed over x squared with respect to x. So this is the same as x squared and minus 8x dx. Now it's easy. We'll take this term and we'll get x cubed over 3. And this term will move the 8 out in front. And this will become x squared over 2. Now, a little bit of simplifying can be done here because that 8 and the 2. So we'll have x cubed over 3 minus 4 x squared plus c. All right. On D, let's rewrite this as fractional exponents, and then once again we can use the power rule. So if we do that, we have 8x to the 1/3 minus 6 x to the negative 1/2 being integrated with respect to x. Go ahead, pause it, give it a try, and then come back and we'll go through it. So on D here, the 1/3 exponent would be elevated to 4/3 because you'd add 1 to it. So your denominator would be 4/3. To simplify that, multiply it by the 8, you flip it, and multiply 8 by 3/4. That gives you 6, x to the 4/3. Similarly here, we get 12, x to the 1/2 plus c. Now on E, we haven't learned how to do the product rule for integration yet. In fact, there isn't necessarily one. There's an integration by parts, but that's not what we're going to be using here. Just simpler to multiply this together first. So I'm going to ask you guys to go ahead, multiply this together, integrate each term by term, and let's see what you get. When you multiply it out, you should get x cubed plus 3x squared minus 2x minus 6, and we're integrating all of that with respect to x. Elevating x cubed, we get x to the 4th over 4. My x squared becomes x cubed over 3, and we bring down this 3 in front. My 2x, the 2 remains in front, and x becomes x squared over 2, and the 6 will become 6x. Then we clean it up. My 3's cancel here, my 2's cancel there, and we get 1/4 x to the 4th plus x cubed minus x squared minus 6x plus c. And that ends, I think, the first page. And we will look at the rest of this in our next video. Thanks for watching.